Hello, here is the second part of the 5.2 work where we're looking at function composition. First, there's exercise 1 here. If you haven't done this yet, now is the time to pause it and do this. Okay, so now that you have at least tried these, let's see the answers. So first of all, f of 2, this is just basic function notation. It just means that instead of x here, we're replacing that with 2. So f of 2 will be 5 times 2 plus 1, and that will work out to 10 plus 1, also known as 11. Same deal with this, it's f of a minus 2, so it's a little bit more complicated. The x is getting replaced with a minus 2. So this will be 5 times a minus 2 plus 1. And you can distribute the 5 in there to get 5a, and then 5 times negative 2 is minus 10, and still plus 1. And that gives you 5a minus 9. Okay. All right, now is where we get into real function composition. So now, instead of the x, we have g of t. And g of t is t squared minus 4. So this means f of t squared minus 4. That's what we're replacing the x with. So just like with f of a minus 2, we replace the x with a minus 2. This is going to become 5 times t squared minus 4, and then that plus 1. So if you distribute the 5 in there, you'll get 5t squared minus 20. And then you can combine the minus 20 plus 1 to be minus 19. And that is f of g of t. So that's the result of composing those two functions. Okay, now this one's a little different. When we're doing g of f of x, the f is now the input into g. So g says take the input, square it, and then subtract 4. That's what we're going to do with the output of f of x. And the output of f of x is 5x plus 1. So I'm going to write this now as g of 5x plus 1. And that's what we're going to square and then subtract 4. Like so. You could leave it like that, or if you want to do 5x plus 1 squared, if you FOIL that out, or use the square of a binomial formula, you'll get 25x squared plus 10x plus 1 minus 4, or 25x squared plus 10x minus 3. I hope that's fitting, just barely in the frame there. Okay, so it looks like f of g and g of f would be the same thing. A lot of people get function notation mixed up with multiplication because it looks kind of the same thing. Like if you were multiplying three numbers, like let's say 7 times 4 times 2, for example, that is the same thing as, computer stuck there. That's the same thing as if you do 4 times 7 times 2, right? This one becomes 4 times 2 is 8, and if you do 7 times 8, you'll get 56. And if you do 4 times 7 times 2, that's 4 times 14, which is also 56. So it works with numbers, getting multiplied together, but function composition is not the same thing. If you swap the order, you get totally different results. All right, so if you got those, well done. Let's go on to example 3. This is an example I'm going to show you this time. But what we have here is these 3 different functions. I want to write them as the result of composing 2 simpler functions. So this y, I want this y here, for example a, to be f of g of x. But the question is, what is the function f? Let's think of the f as like f of t is what, and g of x is what. We gotta figure out what these are, so that if we do this function composition here, the same way we did with exercise 1, C and D, doing that same process, are we going to get 2x plus 1 to the power 5 as the result? That would be expressing this as a composition of 2 simpler functions, f and g. Okay, so the trick here is that let's go back and look at the result of composing these 2 functions here before we, instead of looking at the end like here. There's like looking at 5 times a quantity t squared minus 4 plus 1. There's like an inner function, which is the t squared minus 4, and then an outer function, which is 5 times that plus 1. And the inner function is whatever's getting done to t first. Like if you're going to plug in a number for t, like t equals 3 or something, you do 3 squared first, and then minus 4, and then multiply by 5 and add 1. So that's the inner function. The outer function, the f, is the times 5 plus 1. So here, if you plug in a number for x, like x equals 3, what gets done to x first? Do you do x to the power 5 first, or do you multiply it by 2 first? Well, you multiply it by 2, right? So that should be the inner function. And that's going to be the g of x part here. So that g of x should be whatever's getting done to x first, which here looks like 2x plus 1. And after you do 2x plus 1, then you can raise that to the power 5. So that will be the f of t part. And let's just check that this makes sense. If we do f of g of x here, using these 2 functions for f and g, the g of x is 2x plus 1. So this means f of 2x plus 1. And what does the function f do with its input? It raises it to the power 5. So this is going to be 2x plus 1 to the power 5. And that's what we wanted. So yeah, this here is the answer. That's your the 2 smaller functions that you can compose to get this overall more complicated function. Okay, so then, but you might notice there's other ways to do it. If you were trying this one on your own, you might have said something like, well, what if g of x, the inner function, is just 2x? And then the f of t part doesn't just cube it, it also adds the 1 first. So if this is t plus 1, sorry, did I say cubed? I meant to the power 5. So if you do t plus 1 and then all that to the power 5, that is also going to work. So both of these work. All right, let's look at b. We have 1 over the square root of x squared plus 1 is this function. I don't know why this doesn't say equals y, but it doesn't matter. So again, we want to do the same thing. We want to do f of g of x. G of x is going to be whatever is done to x first. When you plug in a number for x, the first thing you do is you do g of x. And then you take that output and plug it into f. So the inner function here looks to me like x squared plus 1. So that's that. And then if you take that output, what's the function, the outer function, you can plug that into and get this result? It would be 1 over the square root of t. So again, replacing, so if you do f of g of x here, and you replace the input here, the t, if you replace that with g of x, which is x squared plus 1, you'll get 1 over the square root of x squared plus 1. So that's how that works. And you could also do this other ways. You could say, what if the inner function is just x squared? That's okay. Then the f of t part would have to have the plus 1 in it. That would work too. All right. So now let's look at c over here. We have y equals 2 times the quantity 5 minus x squared all cubed. And then that plus 1. So the inner function, the thing that x gets done to first, is the 5 minus x squared. I'm going to make that part be the g of x. And then after you have that 5 minus x squared, what do you do next? Well, you raise it to the power 3, you cube it, multiply that result by 2, and add 1. That's the f of t part. And then f of g of t will be the result you want here. Okay, now this one actually has a few other ways you could do it too, because there's like kind of layers. This function is like an onion with a lot of layers on it. So you could decide where you want the boundary, like where's the inside of the onion, where do you draw the boundary between g and f? You could make g of x just be just the x squared part. And say g of x is x squared, and you could say f of t is 2 times 5 minus t cubed plus 1. That would work. You could also, you could also say the g of x part is 2 times 5 minus x squared, and then all that cubed, and then f of t is just t plus 1. That would work too. So there's a variety of ways to do that. All right, up next you have some exercises. Exercise 2 is really similar to this one. I'm going to show you the answers to these in the next video, but I'll just give you a quick preview right now. Exercise 2 is really similar to this last example, to check if you're getting that concept. if you're struggling with this, instead of looking at the answers in the next video, I recommend to go back and review this example here to try to make sure you understand that concept. And then once you understand the concepts from this example 3, exercise 2 should be totally doable. And then exercise 3 is more like example 2. This is just getting more practice actually doing the function compositions. And exercise 4 is kind of tricky, and exercise 5 is kind of tricky too. So if you get stuck on exercises 4 and 5, that's okay. Feel free to watch those videos. But exercises 2 and 3, you should definitely try to do yourself. And I'll show you that in the next video.